This lesson is going to be looking at another aspect of systems, which is solving systems that are not equations this time, but of inequalities. So I want to take a look at graphing these two inequalities. So the first one says that y is greater than or equal to negative 2x minus 4. That is written in slope-intercept form. So in order to graph it, we have to identify our y-intercept, which is negative 4. So I'm going to put a point at the negative 4. And then my slope is negative 2. So it's technically negative 2 over 1. So that means because it's negative, I'm going 2 down and 1 over. 2 down and 1 over each time. And then to get up here to the left, I'm going 2 up, 1 over. 2 up, 1 over to the left, 2 up, 1 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 to the left. Now, it's greater than or equal to, so that can be connected using a solid line. And then I have my arrows on the ends. So remember, when you're doing an inequality, you have to shade, and it's always in terms of y. So this tells you that y is greater than or equal to that line. So from that line, where does the y get higher or get greater? On top. So then I would take my color and I would shade everything that's up here on top of that line. The next equation, or I should say inequality, is x minus 2y is greater or is less than 4. So that's in standard form, so that's where I need this t-chart thing. And remember, with the t-chart, we made one time each one of the values 0. So if I made x 0, I would have negative 2y equals 4. I'd have to divide both sides by negative 2. They cancel, and y is equal to negative 2. Then my x, if I made y 0, I would have already x equals 4. So I don't have to do anything with it. I already know what x is. So now I can go ahead and put the points on there. So my y-intercept is negative 2, which is there. And my x-intercept is 4, which is here. So now, because it says less than, I have to connect those two. But I have to connect them using a dashed line. And then because y is negative, we shade the opposite. So right now it says that y is less than, but because, like I said, y is negative, we shade the opposite, which is greater than. So I want to shade everything that's above that blue line. Now, when you notice something here, when looking at where the stuff is shaded, I tend to do these in color because it helps see where you have some stuff overlap. You should notice that the shading overlaps. The shading overlaps each other in this section here, right? So as what would lend you to imagine, we switch the slide, that same graph is graphed here, okay? And again, this is the part where the shading overlaps, which is just the same as where we had it on the other slide, okay? That part is the area that is your solution, because that is the area which is doubly shaded. Okay, so sometimes with these you might be asked to identify solutions or non-solutions. So a solution to this inequality would be a point that's in that doubly shaded region. If I put a point down here, that point would not be part of the solution because that point is not in the doubly shaded region. Also, think about what the lines mean. The dashed line means it's not part of the solution, right? So if I have a point that's right here on that dashed line, is it part of the solution? Your answer is no, because it's on the dashed line. But if I have a point right here that is on the red line was a solid line that had the or equal to part. If I had a point there and said, is that point part of the solution? Your answer would be yes, because when it's a solid line, that line is part of the actual solution.